Right? You do that, you put a parentheses, you substitute anything in, put a parentheses around it. Okay, it's how you should do all your math when you substitute anything in, right? You're probably not going to botch that up. Okay, so if you put the work in, right, write the work in, most of you see this are going to go, oh, okay, that's 2n plus 2 plus 1. Right, I have pretty good confidence there. Okay, but if you aren't willing to just put that little bit of work in, right, you easily can say this is 2n plus 2. Right, and you get that a lot, that you just replace it, not realizing I got to distribute, right, the 2 through. Okay. All right, so that's 2n plus 3 over 2n plus 1. How many more absolute value of x's do I have? 2, right? So whether you rewrite this as absolute value of x to the 2n times absolute value of x to the 3, you do the same thing here, or just subtract your exponents, or just realize I got 2 more of them up here than down there, right? I mean, you figure it out at this level, right? So you get the absolute value of x squared. Okay? Yes? Okay. All right, now we do factorials, right? We've talked about them a bunch of different times, really, for the purpose of leading up to today, right? In this chapter, in this section. Okay, so we're gonna have to be able to handle this a lot. N plus 1 factorial is the same as, okay, or n plus 1 times n minus 1 factorial. Or, right, so I just keep chopping 1 off along the lines. Here, I want to stop here because I've got an n factorial in the numerator, right? Okay, but if this was n minus 1 factorial up here, right, then I'd write it as n plus 1 times n minus 1 factorial, and then cancel those out. Okay, so again, I simply take the factorial I have times that minus 1 factorial. And then I can take that one times that minus 1 again factorial, right? So minus 2, I can just keep going down, right? 7 factorial, 7 times 6 factorial, or 7 times 6 times 5 factorial, or 7 times 6 times 5 times 4 factorial. Whatever I need to do with it so that I can cancel another factorial out, right? So you're always taking the bigger one, n plus 1 is bigger than n, right? And subtracting 1 from it until I get the equivalent 1 to cancel. Okay? So my n factorials cancel, and I'm left trying to find the limit as n goes to infinity of the absolute value of x squared over n plus 1. Right? And as n goes to infinity, what does this equal? 0. It equals 0 no matter what x is. Right? Because my denominator is going to go to infinity. My numerator is simply a constant squared. Right? Might be a really big constant, right? As x gets larger and larger, right? But you're still going to go off to infinity in the denominator. So the denominator is going to be larger no matter what x is. Okay? So, therefore, I get a limit, an L value of 0. Which, according to my chart, L, 0. 0 is less than 1. So therefore, it converges for all x's. Therefore, my radius of convergence is infinity. Okay? So, very special case here, right? Or, I mean, I wouldn't say this happens a ton with the problems that we do, right? More often you're going to get something that has an x in it, and you're going to have to, then figure out what that radius is and stuff like that. But there are basically 3 things that you can get here. Okay? We get this where we get 0. That basically the denominator is what kind of dominates the idea, and there is, a radius of infinity. And the interval would be negative infinity to infinity. Okay? Lots of times, like yesterday, we got x, right? We got the absolute value of x over 10, right? And then we set that to be less than 1 and go from there with it. Okay? The third option would be, think about if this was sort of flipped, right? Or the n factorial was up in the numerator, right? Then my final answer down here, I'd have an n plus 1 in the numerator, right? Which means as n goes to infinity, I would get infinity. Okay? With one exception. Which would be when? When x is 0. right? Which is where this series was centered at, right? So literally, the only point that it would converge at would be at 0, right? Which is at the 0 is where it was centered at, right? Okay. So then it only works at one point, right? Which means your radius of convergence would be 0. Right? Okay. So those are kind of there's the two kind of sort of exceptional kind of cases, right? Ones that only work at the center, which means when you do your work here, you'd get infinity as an answer. Okay? Which means the n would have to be up in the numerator. I'd have a higher power of n or higher degree of n in the numerator. Okay? If I've got a higher degree of n in the denominator, I'm going to get 0, which means it converges for all x's, and my radius is infinity. Okay? Or I get the more traditional question that we ask is, like the next one, I'm going to get some sort of, answer with x's and numbers in it or something like that, and then I got to do my math. Okay, figure it out from there. All right, but there's always 3 options. It converges for all x's, radius of convergence of infinity. It converges on some interval, or it converges only at the center, radius of 0. Right, so it's got to converge somewhere, at least at the center. All right. Again, this one here, kind of similar to yesterday's problem, right? Okay. Again, some of you really could just pick up the answer right off the bat and know what L is going to be from looking at this. Right? And if you get your answer, you're kind of like, oh yeah, okay, I can see where that's coming from. Again, ratio test it. Again, it's almost geometric, right? With the exception of the n out here, right? So again, we're going to have that same kind of principle that the geometric, had. So we can kind of recognize this. So n is going to become n plus 1. Absolute value of x plus 3 to the n plus 1 over 5 to the n plus 1 times it by reciprocal, so 5 to the n over n, absolute value of x plus 3 to the n. Right? Again, really okay with you just telling me the answer, right? I mean, this limit's going to equal absolute value x plus 3 over 5. Right? So again, we got the idea here. I've got one more absolute value x plus 3 in the numerator than the denominator, right? N plus 1 minus n, right? So that exponent's going to go all the way, and this whole thing's going to go away, right? Leaving you with this to the first. Same idea is going to happen with the 5s, right? I've got 5 to the n times 5, right? So again, n plus 1 minus n. I've got one more n in the denominator, right? So I'm going to have 5 to the first, so 5 to the n is going to cancel out with all those, right? And then as n goes to infinity, n plus 1 over n is going to go to 1, right? Again, we can factor out an n. 1 plus 1 over n. This n will cancel with that n, right? And so as n goes to infinity, you get 1 plus 0, which is 1, times the absolute value of x plus 3 is the absolute value of x plus 3, divided by 5, right? And so again, ones like this kind of become hopefully somewhat routine of just kind of seeing what's going on, with it. And they're definitely going to be harder ones that we'll look at and figure out, but this comes out to relatively routine. So again, this is what we're calling L, right? So it's going to converge when this is less than 1, okay? Now, again, let's do good notation, okay? Maybe not English, but notation at least is important, okay? Don't just write less than 1 right here, okay? Doesn't make sense. We're saying equals this, which is then less than 1. That doesn't make a whole lot of sense, right? So a whole new line, new expression, right? We have this idea going on here. And what are we going to do then?
Multiply by 5.
Multiply by 5, right? So you get the
Subtract
absolute
3.
value of x plus 3 is less than 5. Which is the form I want it in so that I can identify my radius, which is what's my radius? What's the radius of convergence here? It's 5. And I can identify my center, which is
-3.
-3. All right, this is centered at -3 with a radius of 5. Right, it's in that form that we wrote up yesterday, right? The absolute value of x minus a is less than capital R. All right, so that's what I want. I got it in that form. Okay, so right now I know R is 5. That's my radius of convergence, is 5. The center would be
-3.
-3, okay? So I could then ask for the interval of convergence really quickly from it, right? The interval of convergence would be from
-8 to
to 2. Yes? Right, -8 to 2. Okay? Now, I'm not sure about this yet, right? This is the interval where I know it converges absolutely, right? Which means where it converges, right? What I don't know is what happens at -8 and 2, right? Right. So those would be values I have to go back in and check, right? I'm going to start from scratch on my series and look at this new idea and what's going on. Okay. So again, depends on what the question is asking, and what do I do from that? This question wanted the radius of convergence, so I'm done. Again, if you start finding this, oh yeah, radius of convergence, right? These are 10 apart from each other, right? So therefore I'm going 5 in each direction, right? My diameter, right, is 10, so my radius is 5. We'll look at it in that way. All right. But again, your goal. Ultimate goal is to, at least from a standpoint of trying to identify the radius of convergence, right, is to rewrite the problem so it looks like this, right? So I can get it in that form. It's in that form. Boom, there's my capital R. There's my radius of convergence. Okay. Now, if you're not sure, and again, ideally, from this form, I just know the center is at -3, and then I can just do math. -5 and add 5 to -3, right? Which is where you get -8 and 2 from, okay? Or I do math, right? And I set up that x plus 3 has got to be less than 5, or the opposite of x plus 3 has to be less than 5, right? Here's definition of absolute value, right? Right, so the absolute value of x is sometimes x, and sometimes it's the opposite of x, right? So solve, this would be when x is less than 2. That's working out well for us, right? Divide by -1. This becomes x plus 3 is greater than -5. Subtract 3. X is greater than -8. That works out well for us as well, right? And there we go. Right? This works when x is less than 2 and greater than -8, which is exactly what we got over there by just logically understanding center and radius. This is just solving, right, an absolute value inequality, right? Kind of an algebra 1 skill. Okay? All right, so if, and since we started talking about it, eventually we're going to find that interval of convergence, right? So I need to go back and check -8 and 2. Okay, so let's do that quickly. So right now I know I'm here, right? This is my interval, okay? Again, that is where it converges absolutely, right? So I know it converges between -8 and 2, non-inclusive. Right, so now I got to check my endpoints. So at -8 this becomes -5, so I get the series n equals 0 to infinity of n times -5 to the n over 5 to the n. -5 to the n is the same as -1 to the n. That's 5 to the n. Right? Therefore, my 5 to the n's will cancel. Okay? So really, I'm looking at the series -1 to the n times n. That looks very familiar. Same thing we got yesterday. So basically, this problem is the same as the one we did yesterday, right? Instead of x to the n, it was x plus 3 to the n, right? And so it was shifted, this one's shifted left 3 from yesterday, right? Yesterday was centered at 0, right? And this one's now centered at -3, right? And then we were dividing by 10 to the n yesterday, right? And now we're just dividing by 5 to the n, right? So therefore, this one yesterday was more spread out. This one's more, condensed, right? My radius is only 5 versus 10, okay? So literally the same setup of the problem, right? Nothing really different from yesterday to today. So again, okay, at this point, we've got one main test that we know. A lot more we're going to learn, right? We've got a couple that we kind of know as well. But again, first test we're going to do is the nth term test, right? And so we're going to find the limit as n goes to infinity of a sub n. And again, a sub n in this case is really just n. All right, a sub n is just n. I can again ignore this -1 to the n, right? It's not going to impact what value this approaches, okay? So n, and as n goes to infinity, I get infinity, right? Which is not 0, right? Which is not 0. Remember, the nth term test, you have to get 0. If you don't get 0, you automatically know the series diverges. Okay, so this series diverges, meaning this series, when x is -8, diverges. Right? That's what we found, right? We really found, we kind of found two things, right? We found that this series diverges by the nth term, right? This series right here, this single specific series, right? This one up here is an infinite number of series, right? Because x could be all these different values, right? And for a different value of x, I get a different numerical series, right? Right? When x is 1, I get this series if I wrote it out numerically. When x is 2, I get a different series, right? When x is 1.5, I get a different series, right? So this is an infinite, infinite number of series. This is just a single series, right? This, if I wrote it out, right, I'd have 0 and then -1 and then +2 and then -3 and then +4 and then -5, right? That's a specific, series, right? So this specific series diverges, which means the series I was looking at when, under the case, when x is -8, diverges. Right, so it's not inclusive of -8. Yeah.
So why should I change it from -1 to n? The limit is just n.
Yeah, because again, I'm looking for what are the terms doing as n goes to infinity. I could care less if the terms alternate or don't alternate. If the terms don't go to 0, it's going to diverge. I don't care if one's positive and one's negative. That has no impact on whether or not they approach 0 or don't approach 0. Okay? So if they approach 0, whether they alternate or don't alternate, they're going to approach 0. Right? So it doesn't impact it at all. Right? Really, this portion is only going to come into play and affect me if it diverges, but it works under these conditions for an alternating series test, okay? Which we haven't talked about what those conditions are, okay, but we'll get to that. All right. So most of the work, this -1 to the n, isn't going to come into play unless when I test for absolute convergence, I find that it diverges, okay, under specific reasons, not because of the nth term test, right? If it diverges because of the nth term test, again, as I've said a bunch of times now, you're done. Smile, move on, right? Because the rarity of it diverging, by the nth term test is pretty minute, because we're just not asking those questions, right? We're asking questions of functions that approach 0, right? Because otherwise it's, why are we asking it? Terms are getting larger and larger, it's going to diverge. Okay, great, right? It's just not that valid of a question to care about. All right. So again, a couple of examples, a couple of different series that we're looking at. Again, our initial focus right now is on series that have x's in them, okay? And kind of handling that, right? And so those series that have x's, again, are in a bunch of different series, right? An infinite number of, possible series that we're looking at. And so we're trying to figure out for what values of x, when I look at that numerical series, will that series sum to a finite number? Okay, and so what we're finding here is that for the values between, in this case here, right, for the values between -8 and 2, non-inclusive, right, I still haven't checked 2, right?
It's fine.
At 2, it's going to be 5 to the n over 5 to the n, which is just n, which is going to diverge as well, right? And again, most of the time this kind of happens, like, if one of, they're going to be one, they're the same series, right, but one alternated and one didn't, right? And since if one diverged by the nth term test, the other one's going to diverge because it's literally the same general a sub n, portion for it, okay? But what we're finding here again is that if I put a number in like 0, this series will converge. If I put a number in like 1 for x, this series will converge. All right, but if I put a number like 8 in for x, this series will diverge. Because now I'm going to get 11 to the n over 5 to the n, right? So my numerator is getting multiplied by 11 over and over again. My denominator, along with being multiplied by n, right? While I'm dividing only by 5 to the n, 5 times itself over and over again, right? So again, you've got this 11/5, basically you're multiplying by 11/5 over and over and over again. Besides, we're also multiplying by n, right, to each of those terms, right? So the n is obviously trying to cause the terms to get larger, right? Along with the fact that I've got this 11/5 that I'm multiplying that's getting larger, right? So every term is getting larger and larger and larger as you go through, okay? But what we're finding is that if I put something that makes this exponential smaller than this exponential, right, that the n's not powerful enough to cause it to diverge, right? That this exponential growth, even if they're really close, even if it's at 4.5 to the n over 5 to the n, right? When you multiply by 5 repeatedly, right? Every single time you're multiplying by, a number that's a 0.5 larger in the denominator than the numerator, right? It's just going to continue to just be larger, it's going to grow faster and faster and faster, than it, right? And have an infinite number of those. It's just going to outstrip it, and the n just isn't big enough. It's just not doing enough to counteract, the exponential growth, right? Linear growth, really slow, right? Really slow, right? Compared to exponential, right? They diverge quickly from each other, right? They both get to infinity, but I mean, again, you go out to infinity that way, you probably only had to go out like to 10 to get up to, infinity up that way. I mean, it's just, we're nowhere close to what x value we need or n value we need to get there. All right, so now, when we come back and test our endpoints, right, then our series no longer has x's in them, right? Our series is just based on n, okay? And so then what we're looking at is that one specific series. What does that one specific series do? Okay, does it converge or does it, diverge? Okay, and that's going to be our next thing we're going to look at. We're going to look at, let's see what else we got though, what the x is. All right, so 2 more for you to try. Now these questions are asking you to find the interval of convergence and what the series sums to, right? What would the sum of the series be, right? If I literally could, add up all the terms, right? What would it sum to in that interval of convergence, right? It's only going to sum to this thing for the x values that it converges on, right? So find the interval of convergence and the sum of the series in that interval.